All right, ninth graders. Today we're going to talk about different energy states. We talked about energy forms prior to this, where we had chemical and solar and thermal and electrical, mechanical. We had those different types of energy, but now we can break energy actually up into just two main groups, potential and kinetic energy. And all of those different forms will fall into these different types. So, potential energy is stored energy. And so think about, where do you store energy? We store energy in batteries. We store energy in a rubber band when we stretch it out. We store energy in an object when we place it on a shelf. So, like I said, rubber bands, that's an example of elastic potential energy. If you stretch a rubber band, you have to do work on it to make that happen and to hold it there. And then once you let go, that potential energy is used. Chemical, this has to do with the energy in bonds. So like I said, there are chemical reactions taking place in a battery. That's chemical energy. There is chemical energy stored in food and in gasoline. So that is, those bonds get broken so that we can use that energy. And then there's gravitational potential energy, and that's what we spend most of our time talking about. And that's when we put objects at certain heights. So if I put an object on the shelf, or I put an object on the roof, if I'm standing at the top of a cliff, I have potential energy compared to objects that are below me. Now, we're going to spend most of our time on gravitational, and the equation for that is m times g times h. And m is the mass, g is 9.8 meters per second, and height is the height in meters that the object is. So here's an example. It says, what is the PE, potential energy, of a 10 kilogram book that is placed on a shelf that is 2.5 meters high? So here's our equation again. PE equals m times g times h. And for m, I put in the 10 kilograms because that's the mass. G, I put in 9.8 meters per second. Now, it didn't say that in the problem, but again, that's something you're supposed to know right now. And then the height is 2.5 meters. And so I multiply those three numbers together and I get 245. Energy is measured in joules. And so that's our answer. All right, so the other main state of energy is kinetic energy. And this is the energy an object has when it's moving. Now, an object can have both potential and kinetic energy. It's not either or. The only time an object would not have potential energy is if it's on the gravitational potential energy, if it's on the ground. But a falling object is moving and it's at a height, so it actually has two types of energy. But when we talk just about kinetic energy, we have 1/2 times mass times the velocity squared. So it's the speed and the mass that determine how much moving energy an object has. And obviously, if an object isn't moving, its velocity is 0, and 0 times anything is 0. So the objects have to be moving in order for kinetic energy to be present. Now, if you increase your mass, you increase your kinetic energy. If you increase your velocity, you also increase the kinetic energy. And actually, you can't see it, or right? Okay, hold on. It says, which affects KE more? And the answer to that is the velocity, because if I change the mass here, if I double that, I will double the answer here. But if I double whatever my velocity was, I then square that double, and then that's going to quadruple my kinetic energy. So speed is really the main factor in what changes kinetic energy. Now, I gave two examples here. I only did one. What is the kinetic energy of a 2,300 kilogram boat traveling at 6 meters per second? And so I take our equation, KE equals 1/2 times m times v squared. And then I put in 1/2 is the same as 0.5. It's just easier to type that in. 2,300 kilograms is the mass times 6 meters per second squared. Now notice only 6 meters per second gets squared, not 2300, not the whole thing. It's just the 6. So it becomes 0.5 times 2300 times 36 because I squared that. And that comes out to be 41,400 joules. All right, now let's take a look at this one. I'm not going to do this mathematically. I just want you to think about it. A 50-kilogram boy and his 100-kilogram father went jogging. Both of them ran at a rate of 5 meters per second. Which one has more kinetic energy? Well, if they both have the same V, that's going to be the same for both of them, right? 1/2 doesn't change for either of them, but the father has twice as much mass. So the only thing different is m, and if that's twice as much, then the father's kinetic energy is going to be twice as much as well. All right, that is all we're going to talk about today. There is a worksheet for you to do, and then we'll get into some calculations on Thursday. All right.